Hello and welcome to OneCNC UK. In this demonstration we're looking at PROFFESIONAL 3D. I've already imported a model and we've just put some very basic cutter paths around the back face. There's also a stock model involved for simulation, and the boundaries we'll be using just to create the simple tool paths are the boundary for the billet and the boundary for the open profile. So we very simply did a phasing operation, a mill pocketing operation, finish mill profile and a chamfer. So what we'll do is just very quickly run through this. Right hand mouse click, simulate rest, and we're simulating to a stock model. And you'll see the phasing operation, the high speed pocketing operation, just roughing out the square, finish profile pass and a chamfer pass. That is our first operation. What we're going to do is flip the component over using 3-axis repositioning, which we do by using planes, and then we'll put the 3D tool paths applicable to the part. So we're going to turn off all the layers to start off with and open up the model layer. This is going to be a separate program number, so I'm just going to create myself a new group and I'm going to activate that new group. Now when we use 3-axis repositioning, we position the plane onto the next face we want to work on. Underneath the NC menu you'll see 3-axis machining, which was the first operation. When we left click in 3-axis, these are all the available options that you can have with 3D Professional, and we're just going to select 3-axis repositioning and select OK. It's now a question of moving the plane to the face that you want to machine. Now we want to machine this face next. So we go down into our construction planes. We're simply going to move the plane. We're going to find an anchor point on the base of the model and left hand mouse click. So we've now got a plane on that face. But before you can machine that face, you need the positive side of the plane facing you. So we simply flip that plane over. I'll close that form down, just square project using 3P. Now at the moment, because all I've done is flip the plane over, I really would be able to see what's going on in that little pocket area there behind. So what I'd like to do is rotate it so I can see it. So I'm going to go back into my construction planes. We're going to rotate a plane. And we're going to rotate the plane through Z-axis 180. Now when I tap the space bar and select plane, I can see what's happening in that little plateaued area. Now when you're working with 3-axis repositioning, it allows you to machine and simulate as many axes as you like, and you might very well need to come back and reprogram depths of cut, for example, or tooling. So I'm just going to save that plane and I'll just rename that plane Op 20. Now we have a saved plane. So if we want to go back to our first operation, which is always XY default 0 0, we just tap on XY default, close the form down, select plane. Now we're back to the original operation, and if we need to go back and reprogram up 20, you just simply left click on up 20 and reselect your plane. We want to rough the remaining stock out. As I say, I'd already taken a boundary off the stock model. Because the boundary is now at the bottom of the part, it doesn't matter. The boundary can be anywhere you like. It's the plane that's sat on the top of the job that takes control of the height of the toolpath. So we're going to go into our model toolpath. We're going to use Z level rough, and we're going to change our tool over. Now OneCNC will always prompt you the last tool it used to do a specific operation. If that isn't the tool you want to use, you just simply left hand mouse click on it. That takes you into your recents tab, and your recents tab is populated with tools you are using at the moment, favorite tools that you've got labeled in the library as favorites that you use on a regular basis, or a history of tools you've used in the past. And if your tooling is here, you can obviously select it from here. If the tooling you want isn't there, we go into the libraries. And everything there from ball end mills, ball end mills, all the way down to engraving tools, spot drills and reamers. And these libraries are completely editable. It's just a question of selecting the style of tool that you want. So we'll go with the ball end mill. And we'll just use a 20mm ball end mill for this example. Now, just to show you where the speeds and feeds are calculated from, the flutes and the load per flute control the feed rates. Flute length, tool length and holder style control the collision detection. So we'll just select the tool of our choice and select OK, and you'll see the feed rates calculate. The spindle speed calculates from the billet selection, and again this comes with the software, it's not unique to these PCs. Everything from aluminium, brass, copper, bronze, all the way down to stainless steels. They are completely editable with the surface speed options along the top for your high-speed steel, your carbide, your tick and coated high-speed steel, and your tick and coated carbide. It's just a question of making sure that the applicable surface speed is set correctly. So we'll just select any material for this one and select OK. We could obviously machine the top face off with a standard facing cycle, or you can let the Z-level roughing cycle do it for you. So we're going to allow the Z-level roughing cycle to do it. So we're going to give ourselves a new tool number. We give it some coolant, work offsets, feed control. Now, if your tool is going into a tight corner and it squeals, you can activate the feed control, which will allow you to look into a corner at a given distance, either by using the percentage of the tool or manually typing in what distance. You can obviously select what size radius you want to slow down on, whether or not it's a percentage of the tool again or manual. And by default, it's 50%. So as I'm running along at just under 600 millimeters a minute, when it comes into the corner, it'll just drop down to just under 300 millimeters a minute. If it still squeals, you can up that figure to whatever percentage you want and simply select OK, and that will then tell you that feed control is now being used. A lot of our toolpaths have the option of adjust high feed rate, and when the tool changes direction or moves around the component to take its next cut, do you want it to go around at its normal cut feed rate? If you want to improve your cycle time, we just simply put a tick in the adjust high feed rate and tell it to accelerate the best it can up towards maximum. Now notes, anything you type into that area is visible on the job sheet. So you could be telling the setters to use a 20mm tornado, for example. They know exactly what size tool they're using. And to control speeds and feeds, as you've just seen, you can set up the libraries. Personally, I find it a lot quicker and easier to create templates, and a template is OneCNC's way of remembering speeds, feeds and depths of cut. So if I just right click on the favourites and select save settings, I'll just tell it what style tool I'm using, 20mm tornado, and give it a material. So say I'm cutting K1003M, EM1A stainless, whatever material that tool's cutting. So next time you're using a similar tool with similar material, you just double click on that and it reloads all your speeds and feeds that you used last time. So I'm going to select next. Start and finish clearance, not really too worried about that. All I'm really interested in is rapid plane in Z. How close do you want a rapid off Z0? So just be on the safe side for the first tool till I've got a qualified face, maybe 10mm, but you can go as close or as far away as you want. The plunge clearance is an incremental distance the tool's going to start feeding in from above the material top, which comes down the form a little bit later, and you have an option of retracting at feed speed. Well, I don't really want to do that, so I'm going to select next. These are your high speed options. High speed closed, the tool will stay inside the boundary at all times. high speed open, the tool is allowed outside the boundary and work its way into any upstands. You'll see both of these tool paths have rest machine options. Now, rest machining is where you go in with a large tool to get rid of all the stock. It may be that it's left too much stock in this corner, and in that case you can go in with another tool that's capable of getting in the corner, and the tool will ignore everything else that the tool's just done. And then you have a traditional style tool path, will just spiral in towards the upstand or spiral out towards the boundary. So we're going to allow our tool to start outside the boundary, so high speed open. Because I'm starting outside the boundary, I'm quite happy plunging in, and you have the option of arc optimization, and if you see that box, tick it. Basically, if OneCNC sees a series of lines in the program, it will smooth it out if it's possible with an arc GO2 or GO3. So we've obviously got depth of cut and step over distance that work hand in hand. So let's just say to get the stock out as quick as possible, I'm going to put a 12mm cut on it. That will give me a 15mm radial cut. So I'm just going to ease that off a bit to maybe 25mm. Then you have leave on sides. We do want to leave sides on the top and on the bottom. You can vary the amount of material left on the bottom, and the tolerance of the tool path is 5 microns. Now, as you know, if we're going down at a large depth of cut, to get rid of the stock as quick as possible, we're going to end up with a terrible surface finish that a finish tool will not want to go over. So Professional has the option of reducing steps. And the way that works is once it's taken its 10, 12, 15, 20 depths of cut, and it looks at the model, it sees which surfaces are tapered and which are curved, and then starting from the bottom of the tool path, working its way back up to the top, it does these reducing steps. So we'll just do reducing step 1 just for this example. You can go as fine or as coarse as you like. And we'll select next. Boundary type. What's controlling your boundary? Picked or extent? Well, extent, you tell the billet the size, start and finish point in X, Y, and Z, and the picked is what we've done. So we're just going to select the drawn boundary. If we put 0 in the automatic offset, it looks at the top of the job and the bottom of the job, it tells you where the job is positioned, and 0 is the top of the job. But I've got a couple of mil to come off there that I haven't faced off, so I want my tools to start at 2mm, and I want to machine down to that plateau, which is at -40, and finish. We then just simply select the boundary and right click. You can see the tool path calculating down the bottom. It just take a little bit longer than a standard high-speed tool path because it's calculating all of the reducing steps. Okay, so just so you can see what we've got so far, if I right click on the toolpath group, I'm going to use simulate all because I want to simulate both toolpath groups. I'm using a stop model. We'll just rotate it around because it's been working on another side of the plane. A few options you do have for simulation is we are running with show rapid and shank and holder collision detection, so it's checking flute lengths and everything. As soon as it's finished this chamfer, it will flip it over to its next machining position and continue machining. So we've got a few other options. You can show the stock, which gives the original billet size. You don't have to have this on, it's personal preference. You'll see now the tool is doing its reducing step back up to the top, and because there's 2mm on the top, it will remove that as well. Back plot gives the center line of the tool path on the part as it works its way around. Axis simulation, when you're doing things like 4 and 5 axis work, and then geometry. Any geometry you might have on the previous screen will appear here. You do have different color options. I'm running in random at the moment, so every tool that goes on there puts a different color on. And there we have the roughed out component. So let's continue. I'll just minimize the simulation, and we'll have a look at finishing the part. Now we've obviously got some flat areas to contend with, and then we've got this steep profile. We could obviously go into our surface tools, extract surface edges, and we could create boundaries around these flat areas and use standard 2D toolpaths. But OneCNC has an option for flat area machining. Now, what we're asking flat area machining to do with this particular component is very simplified. Flat area machining is designed to machine multiple flat areas, multiple upstands. And just to give you an idea of what it is capable of doing, OneCNC has direct links to all the help functions. So if I want to see what flat area machining does, you can just left click on it, remove the form that pops up on the screen, and simply tap F1 on your keypad, and it takes you through a full demonstration on what flat area machining does. And as you can see, it's designed to machine multiple flat areas around multiple upstands, and goes through all the tool selections, your height settings, your boundary settings, all the way through to entry styles. So they are very comprehensive help functions available throughout Mill3D Professional. So we're going to use flat area machining. We're going to select a tool out of the library. We're going to give it a new tool number. We're going to give it coolant options and work offsets. And again, you get the option of an adjust high feed rate for when it changes direction. And just like all the other options, you have the capability of creating favorites. So next, rapid plane, quite happy with a couple of mil. Plunge clearance again, incremental distance above where you tell the tool to start. We're going to allow the tool to start looking outside of the boundary. Because we're looking outside of the boundary, we can plunge. Again, we've got arc optimization. And because we're only taking a shallow depth of cut, I'd be quite happy with, say, a 50% step over. As you can see, this is capable of working up to upstands, so it gives you the option of leaving stock on the sides and on the bottom if you're going to use it as a semi-finished pass. The boundary type is picked. Tool placement position, we're going to allow the tool to start outside the boundary. And if you want the tool to cut the top face, you need to look above the top face. It doesn't matter what distance, 0.5, 1 mil. And if you want to cut the bottom face, you need to tell the tool to look slightly below it. So minus 41. And finish. We select the boundary and right click. And there you have all three flat areas machined. Now that's really just to show you what it will do. I wouldn't really want the tool cutting this flat section. You're going to end up with a bit of a trilobal corner that the tool can't get into. And you'd have to go in there with another tool and try and blend in. So I'm going to modify this tool path so it only cuts the top face. So I'm going to go to edit. I'm going to push through this form until I get to the height value, and I'm going to tell it to start looking at -1 and finished. And no, I don't want to repick the path. So we've just very quickly changed so it's only cutting the top face. I'm now going to duplicate that operation. So I've now got a direct copy. So again, I'm going to go back into edit operation, push through that form until I get to the height settings. And I want to start looking at -39 and finish at -41. And as you can see now, it's just machined the bottom face. I'll look at machining this plateau here with a different strategy. So we're now going to look at machining over this profile. So we're going to use Z level finish for this one. Again, we're going to change our tool over in the library. I'll just go with a 12 mil ball end mill for this example. We can give it a new tool number, spindle speeds, coolant options, and work offsets. and we can select next. Quite happy with the rapid clearance set to 2, plunge clearance set to 1. And then your approach options are vertical, where the tool will feed down vertically to the next cut depth. You have a radial approach, where the tool will radially feed on and off after each cut depth. Or you have ramp boundary, where the tool will just gradually ramp all the way around the profile. So I'm going to use ramp boundary for this one. Quite happy with the 3-degree approach. And again, I'm going to use arc optimization. You can, on this tool path, pick the faces if you need to avoid them to machine them with another tool. And you can sketch a start position. Tool direction, I'm going to climb. So next. Now with constant depths, you need a constant surface, whether it's flat, whether it's tapered, it doesn't matter as long as it's a constant taper. When you have steep and shallow surfaces all involved in the same tool path, which is what we've got a shallow start coming over the top, we've then got a steep profile, and then we've got a shallow exit. You'll get a much better surface finish using maximum step over. For this example, I'll just say 0.2. Obviously, in reality, it could be down as low as 1,000. Don't want to leave anything for finishing on the top or on the bottom. Tolerance of the toolpath, I'm quite happy of 5 microns. And we're going to select next. Now we have a couple of flat areas. And if your Z depth doesn't coincide with these flat areas, you could end up with a mismatch. So you have 3 options. You can do nothing about it. You can manually type in these flat areas and add them into the program, or you can simply ask the software to find flat areas for you. So I'm going to use find flat areas and next. Boundary type, again we're using picked. Tool placement position, I'm going to allow the center line of the tool onto the boundary. And to the top of the job, I'm just going to start a little bit above 0.1. At the bottom of the job, I'm just going to go down to the main flat area at the bottom, which is -40. Select the boundary and right click. And you'll see the tool path, obviously just calculating all the Z depths, dripping down the side of the part. It will obviously ignore this section here because it's flat. And Z level is purely for tapered and curved surfaces. Okay, so the only thing we've got to machine now is this flat area. So again, I need to control my tool with a boundary. So we're going to go to Model Tools. We're going to extract an edge. So we'll use Extract Surface Edges for this one. It'll be quicker. And just left click on the square. Now, personally, I wouldn't blend in exactly there. The Z level finish, tool finish there. So I'd like to blend out in a slightly different place just to help improve the surface finish. So I'm going to go to Line. We're going to use Parallel Offset. Let's just offset it by 1 mil for this example. I'm going to double click on the profile and just offset it out. So that's going to be my new extended boundary. So we're going to go back into our model tool. We're going to use Z level finish. I'm going to use the same tool because I don't want any mismatch. Quite happy with the clearance form. So for this one, we're going to use planar finish. I'm going to select a tool. I'm going to use the same tool I just machined the profile with because I don't want any mismatch. All we need to do is confirm the coolant options and the work offsets. Rapid plane, again, quite happy with a couple of mil. We're going to use a zigzag style toolpath. 0 runs along the x-axis, 90 runs along the y-axis, so we'll just use 0 for this one. Zigzag minimum clearance is how far you want the tool to lift up before it repositions. I don't really want it lifting up, so 0. Don't want to leave anything for finishing, and because we've got a flat area, I'm going to use constant step over, and maybe just for this example 0.2. Okay, the boundary type, we're going to use picked. Tool placement position, we need the center line of the tool onto the boundary, so none, and the top of the job is 0. Bottom of the job, that plateaus at about -22, so I'll just go -25 just to be on the safe side, and then we can select the boundary and right hand mouse click, and that is the part completed, apart from possibly running a little chamfer around the square edge. So we'll simulate it, so we can right hand mouse click, simulate all. We're working to a stock model. Again, I'll just turn it over so we can see the first part again. I will whiz this through, even though it's pretty quick. So as I say, it turns itself over into its next fixtured position. I'll just rotate it around and put it into a slightly better place. And using the high speed, as you saw earlier, it just radially moves in at its 25-30% step over, whatever we've programmed. And then once it reaches the upstand, it will then start doing its reducing steps. We'll just whiz that through. It can go up to 100 times. So there's the top section, flat area machining. Down to the bottom. And then finally, it's level machining down the side of the profile. We'll just increase it to get down to the bottom, just so you can see the planar. And there we have it, a little bit of simple 3D Z-level rough, Z-level finish and planar finish. Thank you for watching. If you have any questions at all, please contact somebody on the stand. Thank you.